Okay, I've had a request to do some of the earlier questions in exercise 4.8 and I'm happy to do that. So I've picked question 3, part A, and you can see that we have to do the integral from 1 to 3 of 2 over 2x plus 5 dx. Now if you have a look over here, I've kind of indicated what you need when the integral's a log one. So what happens with a log integral is you've got some function of x on the bottom, and have a look, I've got it highlighted in yellow. So here, it's on the bottom, there it is. And if I've got the function on the top, which I've got in green, so there's the function on the top, its derivative, that is. And do I have its derivative on the top? I do, because what's the derivative of 2x plus 5? 2. So I'm good to go. So that is in fact ready to integrate. I don't have to do anything fancy. You know that the 2 on top, green light to go. So that means I've got the log of that function that was on the bottom, 2x plus 5. Have to evaluate that between 3 and 1. So I've gone ahead and done that. If I put 3 in first, I've got 2 3s are 6 plus 5 is 11, so that's where the log of 11 comes from. And if I put 1 in, I'm going to have 2 times 1 is 2 plus the 5, that's where the 7 comes in. Now remember that log law that allows us to simplify this one? See that line there? There's that interesting log law. Let me just change colour for a minute. I'll see if I can pick something nice. There's that log law that says provided I've got the same base, I can simplify that like so. See, I have used that here. So they are to the same base, they're base e. So that's why log 11 minus log 70 is the same as log 11 over 7. Now they probably want that to, what do they want? 1 decimal place. So that's actually, if I was going to continue on and get back to a normal colour, that is going to be 0.5 to 1 decimal place if you plug it into your calculator. All right, so that's that one. Let's have a look at E now. Now, notice that I have in my original my original integral, I got the integral from 3 up to 4 of x minus 1 over x squared minus 2x. So I needed to be able to get the green light to proceed to have 2x minus 2 on the top, which I didn't have. So that's why in the red you can see I've put the 2 in and doubled the top. But you can't just double things and hope that it's all going to work. It's fine. It's not. You have to actually balance that out. So while I've multiplied it by 2, I then have to fix that up by multiplying by half, which I've done there. So this 2 here got multiplied. Why? Because I wanted 2x minus 2 on the top. Why? Because it's the derivative of the function on the bottom. Once I've got 2x minus 2 on the top, yep, green light to proceed, which means I can now integrate it. So remembering that if I have the derivative on the top and the function on the bottom, the integral of that is going to be a log of that function. So let's have a look. There's the function, which matches this one here. And there's the derivative on top, which is the green light to go, which is over here. Good. So that means I end up with log of the function. So that function goes there, log of that function. All right, so now let's keep going. I'm going to keep the half right out the front. going to plug in now. So log of, well, that'll be 4 squared, which is 16, minus 2 times 4, which is 8. I'm not going to minus the log of. Now put the 3 in. 3 squared is 9, minus 2 3s is 6. So we can work that down. I've got log of 8 minus log of 3. And remember that rule we had up here in the pink? I'm going to use that again. So that's now going to mean that I've got half log 8 over 3. Now I can plug that into my calculator. Let's see if it can cope. Log 8 over 3, and then I want half of that. So I'm getting that that's about 0.5 again to 1 decimal place. That was a coincidence. Okay, good. So we've done that. So the other one I chose to do was question 7. Now in question 7, we needed to figure out an area bounded by x is 2 and x is 4 of a particular function, and the function was this. Function was x over x squared plus 1. Now you've got to be careful, because when you do areas, you've got to ask yourself and figure out whether there's a bit of that function going underneath the x-axis. But between x is 2 and x is 4, let's check that out. Well, that's a squared. We know that's a positive. That's a positive there. I mean, I'm not going to get anything other than a positive between the values of x is 2 and 4. So it's okay. None of that's going to be a problem. So I can just straight ahead. Oops. Don't want to get rid of all of that. There we go. I can just do the integral from 2 to 4. I don't have to split it up into bits that are under the curve and bits that are over the curve, which is cool. Now, you know, as usual, this is the function on the bottom, and I need its derivative on the top, which I don't have, do I? So for me to get the green light to go, I need to put the 2 there and then sort of undo it by going a half. Then I've got the green light to go. And you can see that I've done that over on the integral. Just get rid of that because that looks a bit confusing over there. You can see it on the integral I've done. All right. So that means it's going to be log of the function that's on the bottom, and there it is. And that's the function that's on the bottom. It's the log of it. And now we're going to figure it out between 2 and 4. But remember, there is a half out the front. So I leave the half right out the front. Plug in my values when x is 4. 4 4s are 16 plus 1 is 17. And then I'm going to minus off putting 2 in. 2 2s are 4 plus 1 is 5. I'm going to use that neat little rule that we had a minute ago about what you can do when you minus, and there it is. That's your log law that I'm going to use to simplify this. They probably don't want me to leave it as an exact answer, do they? Let me read. Oh, they want it to 2 decimal places. Fair enough. So I'm going to go log, just looking for it on my calculator. Log 17 over 5, and then I want half of that. So they want 2 decimal places, so I'm getting about 0.61 to 2 dp. Okay, how's that? Hopefully that's a bit of a help. Yay, happy customers. All right, bye.